Alright, so the next little bit, part 2, because I ran out of space on the last video, is looking at the process of bid mass. And there's only a couple of questions on the test itself that might actually pop their head up itself. And examples of that you might come across will be something along the lines of, I'll just change colour because let's be different. It would be like 5 times -6 plus 4. So obviously no brackets there, there's no indices, no division, there is a little bit of multiplication, so you actually have to do that bit first. So making sure we're seeing that we have this is our multiplication, we do that bit first. So let's look at 5 times 6 is 30, and like we saw in the last video, a positive and a negative makes that negative answer. Alright, so 5 times -6 is -30, and then we need to add 4 to that, and -30 plus 4, we think about starting all the way down left on the -30 number line, we need to move 4 places right, we end up at -26. Alright, one more example that's really similar is -3 plus 4 times 5. Same deal, no brackets, no indices, no division. There is some multiplication, so we need to look at doing that section first this time. Alright, so you can see on this side, the multiplication was on the left, this time it's actually on the right. So make sure we're doing the multiplication first. And we will do that by looking at saying 4 times 5 is 20, and -3, obviously the 4 times 5, it's a positive and a positive. Make sure that is a positive there. Now, -3 plus 20, sometimes you might look at it and go, well, that's a bit hard, particularly on a number line, trying to draw that up and work out where you're going. So we can actually just reverse it. Positive 20, because the plus belongs with the 20. The negative belongs with the 3, minus 3. 20 minus 3 is 17. Okay, so that's pretty straightforward in that regard. When we're looking at the indices and the powers, alright, so we might just call that down here, indices slash powers. There are a couple of questions that do pop up along those sorts of lines, and we need to make sure we're thinking about the index laws themselves. So the first index law, I'll just do IL, a little bit easier, is looking at A to the X times A to the Y. Because the because the bases are the same and they're being multiplied, we basically just take the base and then we add the two powers together, x plus y. So if we had to look at that as an actual real life example, alright, if we had 5, even if we had negative, we'll just change that, -5 squared times -5 to the power of 3. Alright, the base, a, -5, they're the same. So we can look at it, say -5 to the power of 2 plus 3 is -5 to the power of 5. Okay, if you were actually asked to find the answer to that, okay, it would actually just mean we're looking at doing -5 times -5 times -5 times -5 times -5. 5 times we write that -5 out. Okay, and obviously to solve, -5 times -5 times -5 times -5 times -5 can be a little bit harder. So let's just look at this. Let's just do -5. I don't know why we've got that that's popped up. That's a bit odd. How do I get rid of that? So -5 times -5. 5 times 5 is 25. And the negative in the negative makes the positive. -5 times -5 again, times 25, times 5 there. Alright, now you're just going to have to trust me that 25 times 25 is, we're just going to group that bit together, 25 times 25 is 625, and then we need to obviously finalise that one by timesing it by the last -5 there. And that's actually going to give us -3,125. Okay, our second index law, just to be consistent, no, it's okay. Second index law is looking at doing a division. So it's saying something along the lines of a to the x divided by a to the y is equal to ax minus y. So again, let's just look at using a example that we might have seen in the book. If we had, let's say the base was 3, and the root on that was 4, and we're dividing by 3 to the 2. Alright, we'd actually rewrite that as 3 to the 4 minus 2. 3 squared. 3 times 3 is 9. That's your answer. Okay. Our last index law that really you need to worry about on the test itself is the third index law. And that actually says this. If we have, I'm just going to change colour, a over b to the power of x. There we go, that's a bit better. Alright, it's actually going to say a, b, x, x, and that's how we end up leaving it. So as a example, we could use something along the lines of 3 over 4, and the power of that fraction itself might be squared, and that just becomes 3 squared over 4 squared. If we need to ask, if you're asked to find the actual answer to that, 3 times 3 over 4 times 4. 3 times 3 is 9. 4 times 4 is 16. You can't simplify this. There's no common factors. So that would be your answer there. Okay, so moving on. If we're looking at fractions, alright, so we'll give that a title of fractions. There we go. And I will do adding and subtracting. Number one rule is when you add and subtract, all your fractions must have the same denominator. So if we have something that just looks like positive 4 over 6 plus 3 over 6, the denominators are the same. We can just basically go ahead and add those together nice and easily. When we do add and subtract, the denominator must remain the same in the answer. And then we just add the top numbers together, the numerators. 4 plus 3 gives us 7. Okay, as a mixed number, 1 and 1/6. There's 1 whole, there's 1 left over, and the answer was out of 6 there. Okay, if they are not the same denominators, so if we had 5 over 6, and we're asked to add 1/4, we can obviously see that 6 and 4 are different there. So we do need to make sure that we are finding the lowest common multiple for those. So 6 and 4, multiples 6, 12, 18, 24, keep going. 4s, 4, 8, 12, 16, keep going. The lowest common multiple, is obviously looking at 12. Alright, so how do we get from 6 to 12? How do we get from 4 to 12? We need to look at multiplying the 6 by 2. We need to multiply the 4 by 3. And what we do to the bottom, we must do to the top. What we do to the bottom, we must do to the top. Okay, so we can now rewrite our fractions to make it a little bit easier for us to add or subtract in this case as well. So 5 times 2 is now 10. 6 times 2 is 12. And then we're going to add 1 times 3 is 3. 4 times 3 we know was going to be 12. Again, adding and subtracting, denominator must stay the same. 10 plus 3 is 13. If we wanted to turn that into a mixed number, how many times does 12 go into 13? It goes in one whole time with 1 left over and then 12 on the bottom. Okay. We will do a little bit of multiplication and then some division to go with it also as well. Alright. So, alright, so again, let's do fractions, multiplying, and dividing. I might have to cut this video short and start again at version 3. I'm just getting a bit short on time. So, when we multiply, we can actually look at just doing the top, multiply with the top, and the bottom, multiplying the bottom. This is a really easy one because there's no common factors that we need to worry about cancelling out. 1 times 3, top with top, is 3. 2 times 4 is 8. And that's your answer. Just multiply top with the top and the bottom with the bottom. Okay. When you do have a more complex question, we had something like this: 5/9 multiplying by 18/10. By all means, we can still multiply the top with the top and the bottom with the bottom, but it can get a little bit harder when you need to simplify later on. So let's simplify now. We need to look at common factors of 5 and 10 and common factors of 18 and 9. So the highest common factor of 5 and 10 is going to be 5. 5 divided by 5 is now 1. 10 divided by 5 is now 2. And then the highest common factor of 9 and 18 is 9. 9 divided by 9, 18 divided by 9 is now 1, and 18 divided by 9 is 2. So we now have a little bit easier work to go around. We take the 1, we multiply it by the 2, we end up with 2 on top. 1 multiplied by 2, 2 on top. 2 divided by 2 is 1 whole. There we go. Nice and easy. When we're looking at dividing the fractions, let's just move down. Fractions. And we're going to divide this time. Key word, or key term really, is to keep, change, flip. Alright, so you might have a question that might look like this. Half divided by 7/4, for example. We keep the first one the same, first fraction is the same. We change the divide to a multiply, and then we flip this one upside down. So instead of 7/4, it is now 4/7. If there were common factors, let me undo that. Erase. Pen. Alright, if there were common factors, 4 and 2, for example, there are. The highest common factor there is going to be 2. 2 goes into 4 twice, 2 goes into 2 once. Alright, again, it's now a multiplication, so we multiply the top with the top and the bottom with the bottom. 1 times 2 is 2, 1 times 7 is 7, and there's your answer.